Okay, so now what I want to do is bring together everything we've learned in order to talk about what we were working towards, which is namely how to determine whether or not an argument is valid or invalid. So let's use a sample argument, and we will take that argument and then we will symbolize it, and then we will test it for validity using a truth table. This is mostly what the exam is going to consist of. So let's take an argument that says, look, the game is on Wednesday or Friday. That'll be our first premise. Our second premise will say, the game is not on Wednesday. And then we'll have conclusion be therefore the game is on Friday. Okay, so what we have to do with this argument is transcribe it into atomic sentences and connectives, and once we do that, we can create a truth table that represents every aspect of the argument, and then we can test it for validity. So the first thing we'll do now is just transcribe it. So I'm going to use W to represent the game is on Wednesday and F to represent the game is on Friday. And so in our first sentence we have the game is on Wednesday or the game is on Friday. Second sentence tells us the game is not on Wednesday, so we negated W. Therefore, the game is on Friday. All right, so hopefully that's straightforward enough. Now what we have to do is flip this argument onto our truth table, and it's going to be just like we've done with atomic sentences and compound sentences in general, only each one of these pieces is going to be represented. So we need a column for W, we need a column for F, we need a column for a negated W, right? Because everything on the truth table has to be represented. And then we need a column for W or F. So the first line is represented, there's a W and an F, both of which are here, and the compound sentence W or F is on the truth table now. The negated W is present, and as we know, the F is already on there. So this is going to be our truth table, and we're going to fill it out just like we've done, just like you guys have done in the previous homeworks, just like we did in the last lecture video. And as always, we're going to start with the rightmost atomic sentence. Okay, so note that this is not an atomic sentence. This is a compound sentence because it includes a connective. So the rightmost atomic sentence is F, and as we know, we're going to alternate one by one. True, false, false. In the second rightmost column, we're going to alternate 2 by 2, as we've done. True, true, false, false. The reason we do it in this order is simply because, as you no doubt know, it exhausts all the possible combinations. Now, negated W, how do we fill that out? Well, we look over here at this column, and whatever W is true, it must be the case that not W is false. Right? So we know true W, false, not W, and then here where we have, wherever W is false, tilde W has to be true. Okay, so far so good. Now we have to determine the truth values for the disjunction in the final column. We're going to look at the column for W and the column for F. And remember, the rule is that the disjunction is true whenever one or both disjuncts are true. So in the first row, we have both true disjuncts, so we know that this disjunction is true. Here the left disjunct is true, so we know that the disjunction is true. Here again we have one true disjunct, so we know this disjunction is true. And then here we have two false disjuncts in which the disjunction has to be false. Okay, so that's the extent of everything we've learned in the last past few lectures. Now the question is going to be, okay, is this argument valid or invalid? The way to determine whether or not the argument is valid or invalid is to see if there are any instances on our truth table where we have all true premises and a false conclusion. So you'll remember from the previous section of the course, which was on basic concepts, and we talked about validity and deductive arguments and so on, where the definition for a valid argument is that if the premises are true, the conclusion must necessarily be true. So what I like to do is label on the truth table where the premises are and where the conclusion is. So this being premise 1, I'm just going to write P1 right here. Premise 2 being the negated W, and then the conclusion being F. Okay, now what we're going to do is look at each row, and we're going to try to find a place on the table where we have all true premises. So we look at the first row. We don't have both true premises, so we just continue on down. Again, we don't have two true premises. Okay, now we have two true premises. And what we have to do is see if the conclusion is also true. So, two true premises, and again, a true conclusion. So, thus far, the argument seems valid. Okay, and then here in this final row, again, we don't have two true premises. So, the bottom line is that nowhere on this truth table are there both true premises and a false conclusion. That makes the argument valid. It's important to know that just because you have an instance on your truth table of all true premises and a true conclusion, that's not what makes the argument valid. What makes the argument valid is that nowhere on the truth table are there two true premises and a false conclusion. So now let's take a look at an example that is in fact invalid. I'm going to use all the same letters, but I'm just going to rearrange the argument. Okay, so in this version of the argument now, I've slightly rearranged things. Here we have the same initial first premise, right? The game is on Wednesday or Friday. The second premise, though, is different. It says the game is on Wednesday, and the conclusion is that therefore the game is not on Friday. This argument is going to turn out to be invalid, and we'll see why in a second. But we need to transcribe the argument, which again, like we said, the first premise is going to be the same. The game is on Wednesday or the game is on Friday. But the second premise says the game is on Wednesday, so we'll just use a W. And then the conclusion is the game is therefore not on Friday. Okay, so now rather than have a tilde W column like we did in the last example, in this example we're going to have a tilde F. And then the final column will be the same though. Wednesday or Friday. Okay. Now again, the way to determine these values is simply to look at the column of the atomic sentence that's not negated. So the negated F is false whenever F is true. So if F is true, tilde F is false. If F is false, tilde F is true. If F is true, tilde F is false. False, tilde F is true. Okay, and then we're going to do the exact same thing we did in the last problem. Namely, we're going to look at W and F, and wherever one or more of the disjuncts are true, the disjunction is going to be true. So you know that it's true in the first row, true in the second row because we have one true disjunct, true in the third row for the same reason, and then false in the fourth row because we don't have a true disjunct. Okay, so again, we've done basically all the hard work, and now we just have to determine whether or not the argument is valid or invalid. So, again, I'm going to label the premises. This is premise 1, W is premise 2, and the conclusion is tilde F. So, again, we are looking for a row in which we have all true premises and a false conclusion. That's going to indicate to us whether or not the argument is valid or invalid, right? Okay, so in the first row, actually let's start from the bottom row because it's going to be more instructive. So from the bottom row, we have two false premises, so that doesn't tell us anything. We're just going to keep moving on. So again, we have a true premise, but we don't have both true premises. Now, in this second row, we have two true premises and a true conclusion. Again, I want to amplify, right? That does not tell us anything. We have to look at every row until we find one row with all true premises and a false conclusion. So here we have two true premises, but the conclusion is true. We have to keep looking. Now we see we have two true premises and a false conclusion. In your homework and on the exam, you need to indicate to me precisely where we have a counterexample, right? So this is what we're going to call a counterexample. Please label it with CE or an asterisk or sign this or highlight the whole row. Something like that to show me that you're saying, look, in this row we have all true premises and a false conclusion. That makes the argument invalid. Let me also just say, sorry, if you would most likely be starting from the top. I always start from the top and move down. And so if you see in the first row that you have two true premises and a false conclusion, boom, you know the argument is invalid, and you can just indicate that and be done. You don't have to find all the, like in some problems there's going to be multiple instances of true premises and a false conclusion. You don't have to find all those. It only takes one in order for the problem to be invalid. So, yeah. But if in the first row you have all true premises and a true conclusion, that doesn't tell you anything. Again, you have to continue and hunt out those instances in which you have true premises and a false conclusion. So that's how we test for validity. The homework will be, I think it's just 6 problems that ask you to transcribe a given argument, like so, create a truth table for it, where everything in the argument is indicated on the truth table, and then fill it out, and then test for validity. Okay, now we're going to look at how to construct a truth table with 3 atomic sentences. So these 4 rows are going to double. Okay, good. Okay, so in this video, we're just going to learn how to make a truth table with 3 atomic sentences. And then in the next video, you'll get to see an example of how this works. I guess let's just start by looking at how the truth values for the atomic sentences will change. So let's just take 3 atomic sentences, A, B, and C, and we're going to make a table. And then let's just take a sample compound statement that looks like this, and then we'll continue the truth table after. The bottom line here is that when you have 3 atomic sentences, 3 unique atomic sentences, you're going to need to have 8 rows of truth values. So when you have 2 atomic sentences, you only need 4 rows, as we've seen. So the formula is basically you have rows is equal to 2 to the n, where n represents the number of atomic sentences that you have. So if you have 1 atomic sentence x, you have 2 to the first, which equals 2, and therefore you're going to have 2 rows. If you have 2 atomic sentences, x and y, 2 to the second equals 4, then you're going to have 4 rows, right? True, false, true, false, true, true, false, false. Okay, now if you have 3 atomic sentences, again, sorry, I'm sure this is pretty elementary, then you'll have 8 rows, which is precisely what we're going to get here. So I like to draw a line in the middle just to keep this organized. You definitely do not have to do that, but that's what I like to do. That's what I'm going to do. I think it's easier for me to write these out and keep them organized, which means it's hopefully easier for you to see. So we are going to begin with the rightmost atomic sentence, which is what we've been doing the entire time. And we're going to continue to alternate one by one. True, false, true, false, true, false, true, false. 8 rows. In the second rightmost atomic sentence, we're going to alternate 2 by 2, which is again what we've been doing. Only we're going to continue for 8 total rows. And then in the third rightmost atomic sentence, or I guess you could just say the leftmost, because we're not going to do any problems that require that have more than 3 atomic sentences. We're going to double again. So we went from alternating by 1 to alternating by 2. Now we're going to alternate by 4. True, 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 false, 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 false. That's it. So I don't want to imply that like, oh well, that's easy, but hopefully it's not too crazy. And then, you know, if you had a not, let's say a not B, you would just look at B's and do the operation where you flip the truth value. But let's continue just to finish out this problem, or not problem, but finish transcribing this this compound sentence. We need all the component parts, right? So we need A or B, and then we need A or B and C. Also, let me take this opportunity to tell you, please take a look at the lecture notes, because I sort of laid this out in the lecture notes with these tables. Anyway, looking over here, right, so in order to determine the truth values of this disjunction, we're going to look at the columns that represent the disjuncts, A and B, and we know now that whenever one or more of the disjuncts are true, the disjunction is true. So here we have 2 true disjuncts, makes the disjunction true. Same here. 1 true disjunct, that's all it takes for the disjunction to be true. Again, here and here in rows, this is the 5th and 6th row, one of the disjuncts is true, which makes the disjunction true. And then again, in the final 2 rows, both disjuncts are false, which will make the disjunction false. Now, I want to sort of encourage you not to get freaked out by this sort of big, ugly atomic sentence. The bottom line is that this is just a conjunction, and so it's going to follow the same rules as the conjunction, namely the conjunction is true when both conjuncts are true. One of the conjuncts is A or B, the other conjunct is C, so we're just going to look at those 2 rows in order to determine the truth values. So here we have a true conjunct and a true conjunct, so both conjuncts are true, the conjunction is true. So you might just ask yourself that as you go down. Are both conjuncts true here? No. So false. Are they both true here? Yes. Both true here? No. Both true here? Yes. Both true here? No. 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 So all these values are going to be false. And so that's how you construct a truth table with 3 atomic sentences. We will not do any with 4. We won't do any that get bigger than this. But yeah, now we'll sort of turn to looking at how to transcribe an argument and test it for validity, which is exactly the same as transcribing and testing for validity with 2 atomic sentences. It's just going to be a bigger truth table. So let's look at that. Alright, so let's take a look at this example in order to practice making a truth table with 3 atomic sentences and testing for validity. Okay, so we have the sentence, it's black and white, or it's gray. Second premise says it's gray. Conclusion is, therefore, this simply just is a shorthand way of writing therefore, it's not the case that it's black and white, or it's not black and white. So, first thing we need to do, just like in all these problems, is transcribe the argument. So, first premise is it's black and white, or it's gray. Now, when you do these problems, you might run into the challenge of not knowing. So you look at this and you say, okay, I know that there's something wrong here. I know that this needs parentheses. But you might ask yourself, well, where exactly am I supposed to put the parentheses? How do I know? The comma will indicate to you where to put the parentheses. So I think it's fairly clear in this first premise that what's being said is it's black and white together, or it's gray. And so we're going to put the parentheses around that it's black and white or it's gray. Again, the comma will be your guide. Okay. Second premise, pretty straightforward. It's gray. And then the conclusion. Now, what I'm trying to, so this sentence is slightly problematic because there's a couple ways you could render it. But what I'm trying to get at here is it's not the case that it's black and white. It's not the case. In other words, what I want here is a negated BNW. It's not the case that it's black and white. You could interpret this sentence as saying it's not the case that it's black and white, but I think that's, I don't think that makes much sense because we're not saying it's not black but it's white. We're saying it's not black, it's not the case that it's black and white. So that negation, that not, is really ranging over the B and the W, which is why I think it's best rendered this way. Okay. Now, how do we make a truth table? Okay. Well, same rules, right? We need to represent everything, every atomic sentence that's in the problem. Sorry, I'm standing in front of it. We need to represent every atomic sentence and every compound sentence in the problem. So, we're going to start the same way, just with the atomic sentences, right? We have B, W, G. We have B and W as its own isolated sentence. We have not B and W. And then we have B and W or G. So, I think the general strategy that I would want to encourage you to take up is to move from the least complex to the most complex. Obviously, we're always going to start with the compound or with the atomic sentences, but then we want to put the least complex compound sentence prior to, in let's just say in ascending order. So least complex to most complex. In a sense, you're going to have to do it this way because in order to determine the value of this sentence, you're going to need both of these component parts, and if you don't have B and W before B and W or G, you're not going to know how to determine those values. So anyway, that's the strategy, that's the order. All right, now we just have to make our table. And then we will just get to work. So, again, as always, we are starting with the rightmost atomic sentence, and we're just going to go down and alternating one by one. True, false, true, false, true, false, true, false. I am going to draw a line here just so that I can keep this a little more visually straight. I know it's probably not, looks like it's going down a little bit, but you don't have, in other words, you don't have to draw this line. I'm just drawing this to try to keep these as straight and neat as possible. So, again, we're going to continue alternating now 2 by 2 in the second rightmost column. And then here we're going to alternate 4 by 4. So again, as we learned, as we learned just a moment ago, we're doubling. We go from 1 to 2, 2 to 4. If we had another column, we would go from 4 to 8. All right. sense, this is the hard work. You just have to read from here. So now, when is a conjunction true? We're going to look at the B column and the W column, and we know from all the homework you've been doing and the lectures that in order for the conjunction to be true, both conjuncts have to be true. I'm noticing that this line is just like egregiously not straight, so I want to fix that. Okay, that looks better. All right. Now, as we were saying, okay, in order to determine the values of this conjunction, we have to look at these two columns. So B and W, both true, so the conjunction B and W is true. Again, both true, both conjuncts are true, so the conjunction is true. Here, in these two rows, we have a false conjunct, and because the rule is that both conjuncts have to be true in order for the conjunction to be true, we know that these two are going to be false, right? If I tell you it's black and white, but it's only black, then the sentence it's black and white is false. Same here, again, we have a false conjunct. We need both of them to be true, so this is going to be false. Again, these all are going to be false, right? Because nowhere in these last four rows do we have all true conjuncts. All right. Now, moving along. Again, this is why we do least complex to most complex, because the next column usually, or let's not say usually, often requires looking at the previous column. So how do we determine the values of, it's not the case that B and W? Well, we just look at the case wherever B and W is true, and we flip it to false. Wherever B and W is false, we flip it to true. So these first two rows are both going to be false. We have true B and W, so not B and W has to be false. And then the rest of these values are all false, so when negated, they're all going to be true. Okay, now, last column. Which columns are we going to look at? Well, we have two component parts. Remember, this is why we learned about the main connective, because the main connective turns the whole problem into just two component parts, or one if the whole thing is negated. So we have B and W as a component part, disjunct, and G as a disjunct. So we're just going to look at these two columns. And again, this is a big disjunct, so all we're going to do here is find, look and see in these two columns, and if one or more of the disjuncts are true, then we know that the disjunction is true. So here, they're both true. That makes the disjunction true. One's true, good enough. Again, one's true, good enough to be true. Both false, that's where our disjunction is going to be false. Okay, again, we have one true, and we have both false. One true, and then both false. All right, so let's say a little tedious and long, but not too bad, right? So hopefully, if this is just like absolute misery for you, then I'm sorry. Okay, so we've done all but one thing, right? We have transcribed the argument, we've constructed the table, we've filled out the table. Now we just have to test for validity. So again, my suggestion is to label the premises, premise 1, premise 2, and we're gonna, and the conclusion. And we're gonna look for an instance in which we have all true premises, 2 true premises in this case, and a false conclusion. And actually, we're a little fortunate here. In the first row, boom, 2 true premises, false conclusion. That's a counterexample. That means invalid. And you can stop there. That's all you have to do. And remember, it's invalid despite the fact that we do have instances in which both premises are true and the conclusion is false. In other words, again, here and here, and here, we have true conclusion with all true premises. But again, just because it happens to be the case that the premises are both true and the conclusion is false, does not make the argument valid. So that's all. I mean, I don't mean to say that's all. That's a decent amount of work, but Hopefully somewhat manageable and hopefully somewhat straightforward. If you have questions, please feel free to email me or come to office hours or email me and we can make an appointment to chat during a different time via Zoom and do some of these together. Okay, thanks again for watching.